So the scenario we had previously on RSR, where we lost in-band management because the BGP session was down and you couldn't receive the VPN labels and the VPN wasn't being sold because there was no BGP LU for the next hop. Will no longer be a problem, right? So basically it resolves this issue. So this feature was fast-tracked specifically for Optus. So it's very good to see that it's landed. So any queries on that, Michael or Stephen or Aaron?
So is there any, I mean, is it a major change? Is it, I mean, like just in terms of testing, what aspects, I mean, is there release documents, at least we can have a look what needs to be tested?
I'm not sure.
Yeah, no, I think so. In terms of documentation, everything is part of the release notes. So you find some note about this in the release notes, which is already out. I think it was out probably a couple of days ago. In terms of testing, I think it probably needs to be tested in the lab as well as part of the regression testing that we will be doing for this data for this release. And that would be including probably putting the router on the scale and seeing what's going to happen when the scales reach, whether it's going to be shutting down the BGP or just gracefully, dropping the extra scale. The expectation would be just not shutting down the BGP, unlike what used to happen in the past and what we faced in the previous releases, that the BGP goes down completely, which blocks everything and isolates the router. So that was actually a requirement from Optus, and this feature has been brought specifically to you guys based on the discussion that we had and the support ticket that was raised sometime last year. So what we did is actually we raised an RFE with Vish and Brian and head of PLMs, and that was actually responded to positively, and that feature has been brought in this release just now. So it's a good thing, and the good thing as well that this feature is brought in this release along with other features that we're just going to be spoken about, which is related to this. So it's good that already.
What does the router do? Does it chirp about losing these routes, or it just sits there and just doesn't learn anymore?
So once the so with 22.10 R1, that's something I'll discuss a little bit later as well. We're introducing dynamic resource allocation, and if resource allocation fails, there is a track set, and also there are show commands showing which application failed to get a resource. So there is additional information available for you. Yes, as it states over there, any additional routes being received are not going to get installed because there's no space left. Okay, cool. So the next announcement, I'm not 100% sure whether this applies to you or not, but if you have seen lag load balancing not working absolutely hashed evenly, then there are improvements in R3 which improves the hashing of traffic. So just kind of highlighting that if this is something that you have seen or used, and it's going to be better in this release. Okay, and the third one that I've highlighted today is the dynamic resource management, right? For label applications, it's now ready for production network. So the feature was introduced end of last year in the 22.10 R1, so that was end of October timeframe, right? But it was released as a non-GA feature, so we did not recommend that you go live with it. But now that the verification and regression has been as past a certain level, right? So and we deemed it as GA ready. So you are clear to deploy in production, and we haven't identified issues with the feature. So just to recap on what that feature was. So in the 22.10 R1 release notes, you have seen that there's a little excerpt about what this is, right? So it's basically saying that dynamic resource management facilitates data path resource allocation based on usage. Right? So tables used to store entries for labeled IP, for example, HPLU, or MPLS and SR use cases can grow dynamically based on usage, right? Which corresponds to increasing number of entries learned and progressed. When other applications are not scaled, label 40 entries can grow and use free table space to store required entries. And the label application table space growth requires compatible features. So as you can imagine, this is kind of allowing you to grow in different dimensions depending on your needs, as opposed to what we had previously explored. So I'll take us through what this is in a little bit more detail. I'm not providing hard numbers today on to what level you can push those individual limits. So that's something that I'm waiting for a little bit more information from the product. But I do know that the Optus scale was tested because this use case was for Optus, right? So the improvements were designed to make sure that you can reach the kind of scales we expect, right? So let's go to the details, right? So now, prior to this release, you had to and you encountered some design challenges, right, to mitigate the Gen 1 fixed scale profile. Right? So basically, your MPLS, NHLFE, next stop label forwarding entries are MPLS labels you need to forward traffic to the network. And to ensure that you could fit within the table space available, you have to do things like, maybe consider a smaller IGP instance, like, less number of routers in the L2 domain, or partition filling, right? That was one of not desired. You also have to kind of like try to avoid parallel protocols, avoid TMP if possible, and you also have to enable things like selective label download. The unidirectional label route, also you have to kind of figure out things like route constraints, change to label per service, selective label download, also minimize multipath or edge-pick utilization, or like even completely not use it, just to kind of fit into the profile scale. Right? So obviously these things are cause you to figure out how I'm going to run this box in the network, and you have to sacrifice features that you may want in the network. Right? And you could avoid some of this by having a hierarchical service design, but then it also increases additional complexity also. Now, there was pretty much nothing you could do about the label swap for inline sort of behavior, because that's just something that's required. So in some of the scale areas, there was really nothing you could do from a design point of view to mitigate. And you can see what the MPLS scale gap was, right? So you wanted SRRFIs with TLFA of like 4K, but you can only do 2K, right? And that was shared with other things as well. BGPLE, you wanted 4K, you could do maybe 3.5 and then stop. BPRL labels, you wanted about 8Ks, you only want 4Ks. So these things were just a recap of what the behavior is prior to this release, right? So what happens with, and the reason for all of this is because on 22.10, prior to 22.10, right, the memory space on the forwarding line chip was pre-allocated on a fixed basis for the applications that the box supports. Right? They don't grow and shrink. If you're not using ARP entries, you cannot reallocate the spaces on the gates. It's just committed from day one. While it's good to ensure predictability, like I can provide you with a scale table and say that, yeah, as long as you don't hit any of this, you can simultaneously get to all that scale. It means that you're limited, you just have this rounder sort of scale profile, and you can't push it in any one direction based on your needs. Right? With the 22.10, what happens at boot time is that a minimal space is allocated per application, right? And the rest of the space is available for grabs as needed. So the allocation is on a per bank basis, and each bank is about 4K entries. And depending on the application, some of them will use one entry at a time. In other cases, you might use 2 or 3, or whatever the case may be for that application. But the bank allocation is on a 4K basis. So this helps a lot, will help you a lot to push your network in the direction you want. There is a couple of things to be aware of. So the base allocations that are made for applications, like there are some applications that are not part of dynamic process applications, so they have a kind of a fixed range, right? the release, not the release notes, the section 5.19 from the basic system configuration guide that I referred to in the emails a while back, actually goes into details about that. So these are like the non-label applications. So they are allocated on boot. However, there are configuration options available where you can set that, okay, I want to allocate so many entries for router applications, right? Maybe 4K, 8K, 12K. I think in your case, you have very few actual IP interfaces in use, so you could go with the lower amount. And that frees up 2 more banks for your label applications, right? So just making that aware that while these options are available, these are read at boot time. So if you choose to modify them, you would have to reboot the router. Right?
So in the part of the testing, would we come up with an appropriate profile for Optus?
Yeah. So I think so. This is one of the areas where we need to work together on what to enable or to disable. There are also certain applications that you can completely kind of disable, but it depends on which version of IXR you have. So I think in the IXRE maybe not, but in others they would be. Yeah. So we definitely need to discuss the best way for you to do this. And I always say you want to free up as much as you can so that you can have more labels as well. Okay, so from a diagram point of view, that's sort of on the left is before and the right is after. Right? So on the left, things were allocated, hard allocated, and was done. On the right, you have some minimum allocations, and then you have a bunch of banks that are occupied. Okay. Okay, from a visibility point of view, right? So once you do tools dump, you're going to see a different kind of output from what you've been familiar with. There's a bit more extension of how the individual applications are using the resources, right? And you also have this visibility of how many banks are available, how many are located, and which applications are using it. So, so hopefully this will help us as we start loading the box and also doing your operational growth as well. You can kind of monitor and see how things are going. Right? Handling of failures to allocate. Okay, so this is kind of important, right? So there's not a lot of visibility of what failed to get allocated today. So there's a lot of improvement in this space. So you have a couple more tools dump options in a show command that will help you find out what's going on, right? So for example, if there was a bunch of MPLS next on failures and the cards were affected, you can see them. If there was a specific panel that could be installed and failed because it was in space, you'll also see them as well. In addition to this, there will be events created for this. So your monitoring of the box will be informed that exhaustion and there's been failures for exhaustion. And that's it. So that's sort of a very quick overview of improvements that we're getting this week.
So the software upgrade was pre-knocker or after the knocker? What was the plan?
Which one? Not before. Before knocker.
Before knocker.
So yeah, we should actually start testing that in the lab ASAP.
So Maria, have you included that in the project plan that all the required regression testing for the software upgrade has to be taken care before we go for knocker?
On this one, Raj, on the steering committee, was